All right, let's try a little bit more with the angle addition postulate here. So real quick, just so we're all on the same page here, what does this little symbol down here mean? Yes. Yes. It means it's a right angle. It's 90 degrees. So keep that in the back of your mind. So I'm going to put another angle in here, or a couple more angles, I guess, technically. All right, and let's say this is x plus 15 degrees. I start to hear the groans. And then 5x plus 57 degrees is that one. So yes, I'm putting a little algebra in there now. Okay, stick to your guns. Okay, the concept behind it does not change just because I put an x in there. Okay, so I want to figure out what is the measure of angle ONP. Now, when there's algebra involved, that means I have to figure out the value of x before I can go get that. So we have to come up with a strategy using the angle addition postulate and that right angle to get after x. So does anyone have an idea of what we could do then? Yes, Zach?
Add the two angles together.
Add the two angles together, okay. So 5x plus 57 plus x plus 15. And do what with that? Yes? Equal to 90. Name again? Tyler. Equal to 90? Okay. Does everybody see how we just used the angle addition postulate there?
Yeah.
Okay. We still used it. Okay. It's got x's in there, but who cares? We still used it. And what we did was we used that to set up an equation we can then solve. Okay. So we had our geometry hats on at first there, right? Now we've taken the geometry hat off, we've picked up our algebra hat, and now we're going to do some algebra. Okay? So ignore the geometry, ignore the picture for now. Just focus on the equation. Let's get through that, then we can go back and finish it up. So, how do we solve this equation then? Somebody give me a good first step? Yeah? Add some like terms. Good. All right. So 5x plus x, 6x, 57 plus 15 would be 72. Okay, somebody else? Get me through the rest of this thing. Somebody hasn't spoken yet. You have. You haven't.
Taylor and subtract 72 from both.
Alrighty. Thank you, Taylor. 6x, 90 minus 72. 18, right? Okay, and so what is x then? 3. Yeah, good. X is equal to 3. Okay, so let's go back to the geometry side of things. If x is equal to 3, and I want to find ONP. ONP is this angle down here. Take a look. X plus 15, right? Is that one? So what do you suppose I got to do? Somebody who has not answered something yet. Yes?
Dominic, and you do 3 plus 15.
Right. Thank you, Dominic. 3 plus 15. So just plug it in. So that's going to be 18 degrees. Be the answer to that one. Alrighty. So angle addition postulate, we can use it with just numbers. We can throw some algebra in the mix. Okay, but that's how we can use that to solve some problems. Yeah? Yes, you may. All right. Last thing I want to talk about, and then I'm done, is an angle bisector. We've talked some about bisectors already with segments. What did a segment bisector do to a segment? Yeah.
Zach?
Yep.
And wasn't it like intersection?
It intersected it, but how? So it always intersected at the segment's what? Yeah.
Taylor and midpoint.
Midpoint. So it always broke it right in half, right? So a bisector, and the prefix bi means two, right? So a bisector breaks it into two equal parts. So a segment bisector broke that segment into two equal pieces, or two congruent pieces, okay? Well, what do you suppose an angle bisector is going to do then? It's going to break an angle into two equal-sized piece angles, right? So I have some angle. Where are we at in the alphabet? R. So we're going to call it RST. So an angle bisector, if we're going to have something that comes through and breaks this angle into two congruent angles, again, it could be a segment, it could be a ray, it could be a line, something straight that can come through and break it. So I'm going to make a line for this particular example. And QRSTU. Okay, so if the line US, and don't forget the proper notation there, a line has two arrows. So if line US bisects angle RST, then angle RSU is congruent to angle UST. Okay, that's what's going on. And to show that those two angles are congruent, just like we can mark congruent segments, we talked about that. With angles, if you put just one little swoop on each one of them, I call them swoops. I don't know what they're actually supposed to be called, but that indicates that those two angles are the same size. Okay? And if you have other congruent angles in a picture, then maybe you do like 2 swoops for those, or maybe 3 swoops or something. But yeah, so that indicates we got those two are congruent. Okay, so if you have a picture and they tell you this thing is bisecting this angle, that's automatically giving you this information then, right? All they need to say is this thing here, that's a bisector. And then you've already got a couple of congruent angles in there. Okay, so let's use that, see if we can solve a problem involving that. And if we're good there, then I think we're done for today. So let's say ray VW bisects angle XVY. All right, and then I'll draw a picture to go with that. Dope. Okay, so there's my picture, and VW is that ray that is bisecting the angle XVY. Okay, and let's say this angle is negative 3x plus 130 degrees, and this angle over here is 4x minus 10 degrees. So we're going to do a little algebra again. Okay. And let's say we want to find the the measure of angle YVW. Yeah, if you can't read that, it's negative 3x plus 130 and 4x minus 10 are the two. And YVW is the measurement we want. Okay, so if it's a bisector, what does that tell us? Let's have somebody who hasn't answered something yet today. You guys both have. Yeah. Right. Oh, name? Oh, I didn't hear it. Sorry. Yeah, but they're, okay, so thank you, Jason. They are equal, right? Those two measurements. Okay? So that's giving you a way to set up an equation again, right? We can take those two algebra expressions, 4x minus 10 is equal to negative 3x plus 130. And now we got to take off our geometry hat, put on the algebra hat, do the algebra. Okay, so I'll quickly do that. Going to add 3x to the other side. Okay, start with that. So we got 7x minus 10 equals 130. And then add 10 to the other side, so 7x equals 140. Divide each side by 7. X equals 20. Okay, so once I know x, then I ask myself, okay, what am I really trying to find? I'm really trying to find YVW. Where's YVW? Boom, right there. So what am I going to do? Just plug it in, right? 4 times 20 minus 10. All right, so 4 times 20 is 80 minus 10, 70 degrees. I just used a bisector to solve the problem. Thank you. All right, so that's pretty much it. I'm going to have you guys, you're going to do a little page in your journal, and then you guys have a homework assignment out of your book. Okay, got about half hour, a little more left in class here, guys.